Okay, first of all, some clarification over here quickly. For today, I'm going to talk more example about the equals method. So it's not really the new topic, just to strengthen your understanding. So this part will be covered in the lab test 1 next Monday. Okay, just to clarify, only for this part. Okay, I'll make a later Moodle announcement to make it clear. But for the first part about equals method, just more example to show you to strengthen your understanding. For the second part, I'm going to talk about comparable and compare to. You might have seen this in your lab number 2. Okay, I'll just talk about it. It's quite an easy concept. And then when you see a method called hash code in your lab number 2, don't panic too much. At the moment, simply imagine it's a little bit like a get BMI. You're simply giving your attribute values for the domino. You want to calculate some integer value as a return based on some formula. It's quite clear from the API what you should do. But we'll talk about the complete story about hash code on Monday. Okay, that's what we'll do. Okay, that's about the plan for today. So today, first of all, I would like to recap very quickly about equals method. Okay, remember we talked about case 1 and case 2, and then I got lots of JUnit example to show you. We'll go over together to make sure you completely understand how the equals method work. So we talk about equals method. First of all, you have to understand there is already a default version of the equals method from the object class. And the object class, every class that you define in Java is going to inherit from the object class, which means you accumulate all the code from the object class. And the equals method is simply just one of them. Okay, so case number 1. Okay, let's say we define case number 1. We have a class called point version 1. The point version 1 looks like this. So point version 1 is a class over here, and then it simply defines x and y and also the constructor, and that's it. Okay? It does not explicitly redefine the equals method. So what does that mean? That means if you're trying to compare two point 1 objects for equality by using equals method, it is always going to call the default version from the object class. Okay, that's version 1. Okay? What about version number 2? Version number 2, okay, again, so you got P1 and P2 of point V1. Sorry, there's a typo here. This should be 1. That's what I meant to say. Okay, point V1 here. And then when you call the equals method over here, it's going to be this default version that's going to be called. That's version 1. What about version 2? Version 2 means you're not so happy with the default version that's inherited from the object class. The default version does nothing but it just compare the two objects by addresses, just object comparison. If you're not so happy with it, you can definitely customize your own version of equals method, which is often the case. In which case, let's say I got point V2, let me use a different color here. So you got point P2, point P2, point V2, and then you got P3 and P4. In this case, if you try to call the equals method, now you gotta be careful which version is it going to call. In this case, you can see we got two versions of the equals method. Let me show you. Let's say we have the point P2 class over here, and then besides the two attributes over here, we also explicitly redeclare or redefine this method again, equals method. And over there, we follow the pattern that we explained last time. I'm going to let you revisit the lecture recording if necessary. And then we simply say, after doing some typecast, okay, we're going to say the x attributes for this object here is the same as the x attribute for other objects and also for the y, right? That's like our customized version. So now we got two versions over here. So when you call the equals method, where the context object over here, I want you to focus on the context object, P3. P3 was declared of type version 2 for the points. So that means we're going to call this version of the equals method rather than the default version. Okay? That's a very quick recap of what we said last time. Okay? Any question about this, the big picture, before we see some code for JUnit test? Are we okay? Okay. So now let's have a look at, I want to have one slide to show you first what can you do for equals method for JUnits. One slide to summarize what you should know. There is an assertion called assert same, okay? And then you can pass two object variables over there, obj1, obj2, for example, p1, p2, or p2, p3, etc. So what does it really do? It does nothing but, it's basically equivalent to the following. To say, I want to see if obj1 over here equals obj2. If they refer to the same objects in the memory, which means obj1, obj2, are they talking about the same address? That's what assert saying does. For example, let's say this. Let's say I simply got, let's say, point v1, and also I got p1 objects, also got p2 objects, right? So p1 and p2, they are different addresses. If I try to do, let me do another one. Let's say another point v1 object here, p3. And then I simply say p3 is assigned to p1. What happens after this assignment as we talk about aliasing? P3 and P1, after the last assignment there, they should point to the same objects. Okay? So that means if I try to do assertion over here, if I say assert same over here, P1 and P3, should it pass? They should, because P1 and P3 point to the same object, right? Because of this assignment over here. Because you say P3 is assigned to P1. On the other hand, what about assert same P2 and P3? In this case, they are not the same objects. So easy, they just fail. Questions? Yes, because you can see that from here. Remember, we talked about in the review lecture. So over here, you see point v1, you declare p3. P3 simply copies the address that's stored in p1. So they refer to the same object, yes. Okay? Okay, that's about the assert same. Very easy. The tricky one, which I will show you by various examples, let's just talk about principle first. The tricky one really is assert equals. Notice that I chose the name for the argument very carefully. I simply say expression 1, expression 2. I didn't say object 1, object 2. Because for assert equals, you may compare primitive values or you may compare reference variables. Okay? Let's talk about the easy case, which we also know from the previous lecture. If expression 1 and expression 2, they're simply primitive types. They simply mean you try to compare their values. For example, let's say over here, let's say I got integer I being 10 and j being 20. If I say assert equals I and j, you can see I and j here are simply just primitive types. They only got value. There's no addresses whatsoever. So it will just be fail, right? Because I and j, they are storing different values. Okay, that's an easy case. Now, things will get a little bit trickier about if they are reference types. Okay? This is a principle you have to remember. That's why I did a recap in the first slide in the iPad, because there are two cases for the equals method. When you see assert equals over here, where the two expressions are reference types, it's as if you try to call expression 1 dot equals expression 2. It's as if. However, we know that the equals method may not necessarily have been redefined explicitly in the corresponding class. So that means we got two cases to consider, right? Case number 1. Let's see, let me just ask you this question here. What if, let's say, for expression 1, I'll give you a concrete example. Let's just think conceptually. Let's say expression 1 is of type point P1. Let's point version 1. Point version 1 does not explicitly redefine the equals method, right? So now, if I try to say P1, and let's say P1 and P2, they're both of type point V1, let's say, okay? And then I say assert equals P1 and P2 in this case. It would be equivalent to saying P1 dot equals P2. In this case, what happens? Which version is going to be called? Default or customized? In this case, default, right? There's no customized version over here, okay? It's really important for you to keep in mind, okay? If it is not declared, then it will just be the same as the default, which is to compare the addresses, just the same, okay? I will illustrate this by some concrete example on the iPad in just a moment. Okay, let's say this, for example. Let's say we got P4 and P5, right? And now we're saying point V2, where we do have the equals method explicitly redefined. So we got P4 and P4 and P5, right? P4 and P5 over here. And now, what happens if I say P4 and P5 over here, assert equals? Which version do we call in this case? It would be equivalent to saying P4 dot equals P5. Now, all you got to decide is whether P4's type, which is point V2, does it have the equals method redefined? It does. So that version will be called. Okay? As easy as that. Okay, so that means it will pass because 3 and 4 and 3 and 4 over here, they're the same x and y coordinate values. And what about another quick example? What about P1, P2 over here? If I say assert equals P1 and P2 are simply up there, right? P1, P2.
How do we know if the equals different?
Oh, you gotta look at the class definition. How do you know? Look at the class definition, okay? But we know already from the previous lecture, so we got point version 1 and point version 2, right? So now in this case, if you look at P1 and P2 to say assert equals, we know that P1 and P2 was declared point version 1, which does not have the explicitly defined version. So now when we say assert equals P1, P2, what is that equivalent to? P1 equals P2. We are calling the default version, which means that should fail, right? Because they are not the same objects. A tricky question for you over here. What about here? Let's try this one here. I will explain all the cases in detail. I want to give you an overview. What about assert equals P4 and P2? I want to know two things. True and false is not so important over here, okay? Well, of course it's important as a final answer, but P4, P2. First of all, I want to know exactly which version of the equals method will be called. Which version? When I say assert equals, okay, that's right, okay? Anyone want to try? What is that equivalent to? P4 dot equals P2. And what's the type for P4? P4 is of type point version 2, right? And point version 2 does have the redefined version. So the redefined version will be called, okay? And let's have a look at the redefined version. In this case, remember P4 and P2 over here. If you look at P4 and P2, P4 is of type point version 2. And P2 is of type point version 1. They are different types, agree? So now, let's look at the definition there, as we discussed last time. Over here, which case would I hit? Get class, exactly, thank you. So over here, you can see over here, this will be the case because remember, the first one is going to be of type point version 1. And the second object there is of type point version 2. They are different, so just return false for that case. Okay, so what my point is, when you review the lecture, I would like you to see exactly here. If you look at the last assertion here, assert equals P1, P2, and also assert equals P4, P2, both of them fail, but for different reasons. Okay, that's something I want you to remember. But I'll repeat this one more time when we see a different example. Okay, any question until now? Basically, this slide is telling you in JUnits, you have options to use assert same or assert equals. But you have to know what you're doing. Or when you're reading somebody else's test cases, you should know what they're doing. Okay? I will go over examples. Okay, let's now go over examples together. Okay? I would like to go over the first one over here. Let's go over together. Okay, let's say this. Okay, let's look at the JUnit test. Let me just tell you the things you have over here. You got everything you need to make a judgment. First of all, you can see that this is the class for point v1. Okay, point v1 is here. And there is no equals method redefined, which means we're going to use the equals method from the object class. Okay, that's clear, right? And now, I want you to look at the test case. Let's go over line by line. Line number 1, we create P1. Line number 2, we create P2. Okay, so after these two lines, what we have is we got P1 here and P2 here, and we simply got the type, I would say point V1. And also point V1, the same type. And one of them is 3, 4, the other one also 3, 4. Okay, let's try to do some assertions. What about P1 equals P2? That should be false, right? And the reason you can see, in order to make the assertion pass, I simply say assert false. Do you see the logic here? Okay. When I say assert false, I'm saying that this Boolean expression here must return false. Indeed, it does return false. On the other hand, over here, if I say something like this, if I say assert true, and then I put P1 equals P2, it's going to fail because P1 equals P2 is false. Is it possible to use assert true, but just tweak this expression a little bit? Yes? Yes, I agree. Thank you. So I can say assert true here, and then I can simply say not equal to. Okay, very good. Okay. Okay, similarly, if you say P1 equals P2, that'll be false. Also, P2 equals P1 is also false. Agree? Okay, that's easy. Now, similarly, if you try to do assert the same over here, remember I said for assert same, this case is simple. It's just equivalent to saying P1 equals P2. So now in this case, assert same will just fail because they are not the same addresses. Okay, that's why I just commented out so you don't get any assertion failure. Now let's look at these two lines. Assert equals. I simply use P1 and P2 in different orders. But let's look at the first one. When I say assert false, and then I say P1 dot equals P2. So now what you need to decide is when I say P1 dot equals P2, which version it is going to call. So always, if you want to decide which version is going to be called, my advice is look at the context object over here. And P1 was declared to be of type .v1. That means the version from this particular class is going to be called, right? But there's no explicitly redefined version, so the version from the object class will be called. Okay, that's kind of the chain of reasoning here. So now when I say P1 dot equals P2, what would that be? False, because, well, the expression here will be false. So when you say assert false, that'll be pass, okay? You simply just compare references. And similarly, when you say P2 dot equals P1, the same. Okay, and finally, so over here, since we haven't got any equals method redefined, so the best we could do is simply just write down some expression to express what you really mean by equality. Let's say x and y should be equal. Okay, just show you one example. Any question about sort of like a case number one over here? Yes.
For your assert false P1 dot equals P2.
Yes.
You're saying that dot equals exists in the point V1.
Should be return false. Yeah. So over here, assert false. Your question is more about the assert false or the equals method? The dot equals. Okay. So let's see this. When you see dot equals over here, in order to determine which version of the equals method will be called, you have to look at the context objects, which means to the left of the dot, which is P1. Look at its type. P1's type is .v1. So that means we're going to find in .v1 class. And then in that case, you can see there's no explicitly redefined version. So that means it's going to be inherited from the object class, which is this version here. Okay, good. Let's look at case number two. Similar, but let's look at that together. So now I'm talking about .v2. Okay, the one with the version equals method redefined. So you can see .v2, and .v2 is over here, and we do have the equals method redefined. We do have it. So that means you can see the version from the object class is gone. It's not relevant anymore, just not relevant. Okay, so now let's have a look at that. First of all, if I say assert false, okay, how about this one here? When I say, just focus on this, P3 equals P4, false or true? False, right? We still compare addresses, okay? Let me draw extremely quickly. So P3 and P4, they're still pointing to different objects, but of different type, .v2, and also .v2. So we got xy, 3, 4, and also we got xy and 3, 4, right? They're different objects, so this should be false, right? And assert false is going to give us pass for that particular assertion. And similarly, when you say assert same for P3 and P4, they're different objects, so the assertion should just fail, right? Let's look at a more interesting bit. I want you to look at this, these two first. These two, okay? The easy case. So let's say P3 dot equals P4. Let's do similar reasoning. I want to know which version is going to be called. So what should I look at? The context objects. So I will circle the context object here, which is P3. P3 was declared to be of type point v2. That means I need to look at point v2 class, which does have this equals method redefined. So this is the version to be called, right? So now when I say p3.equals p4, I'm talking about p3 and p4 here, right? So now if you try to execute a code, which branch is going to be hit? Well, think it this way. Let's just do this execution in detail for this one here, okay? So now you can see P3 is going to be this, and P4 is going to be other, actually obj. Okay, so P3 is going to be this, and obj is going to be P4, like that. Okay, first of all, we see P3 equals P4. We know that it's not the case, right? They are different objects. So the if branch is not going to be executed. What about second branch? When we say obj, in this case, P4, right? P4 over here. P4 is null. Not the case. No, we are not going to hit this. Okay, so we'll continue. Now, this, which is P3, P3.getClass and P4.getClass. What is that? Both of them are the same, right? They are both point v2 class. So not equal to is not the case. So false. So we also don't hit this branch. So then if we go to the step number 4, we simply try to cast obj. In this case, it's simply just P4. You can think of it like that. Okay? And then we just cast that, and then we got something called other. So other is also pointing to this particular P4. Okay? And then in this customized version over here, what do we compare? We are basically comparing, so P3 is this, and P4 is other. So P3.x equals P4.x. That will be true. Similarly, P3.y equals P4.y will also be true. That means eventually what we get is true, right, from here. That's how you trace the code. Questions? Which one? You mean this one here?
Yeah.
Okay, no problem.
No, just
Which one?
the object that you made, the others.
You mean over here?
Yeah.
Oh, the cast. Okay, let me make this, you mean why we do the cast, or?
No, I thought you were making a new object.
No, we are not really making a new object. Okay, so the story will be much more complete after the reading week. I would say for now, it was simply just doing a cast so that, okay, very.
Do you have the point class? Oh, we do, right?
We do have the point class, yes. As I said last time, if you did not have this line over here, let's say hypothetically, if you did not have this cast, and you simply say, rather than other.x, you simply say obj.x, it is not going to compile. Only the cast will make it compile. And there's a reason behind that, which I cannot just say that now. It's a bit too complicated for now. Okay, I'll leave that until the reading week. For now, take it for granted. Okay? Good. Okay, so we know, similarly, P4.equals P3, I'll let you trace it. It should also return true. So now the last part will be this over here. What about these two? Assert equals P3, P4, assert equals P4, P3. Yes? Where? Which part? You mean the code or? Okay, in where here and whereby? Oh yes, I meant point v2. Yes, you're right. Maybe I should fix that. Thank you. Yes, I definitely meant point v2. When you see the source code, I don't have this kind of typo. I just type it by myself. Okay, but on the Eclipse, the source code I made available to you, they just compile. Okay, that's about it. And let's discuss this. So now remember what I said before. When you see assert equals over here, it simply does P3 dot equals P4. That's how you can think of it. So now we need to decide which version of the equals method will be called. Again, look at the context objects. In this case, it is P3 context objects, which is defined as point P2, point V2 class. So which version is going to be called? The customized version, which is over here. Okay? So it's really the same as this assertion over here. I want to tell you that these two assertions turn out to be the same, just equivalent, simply because we redefined the equals method in point V2. Questions about this? Are we okay? I hope that's clear. Okay, and you can do the similar reasoning for the last one, just the same idea. Let's go to the third case. The third case basically mix the two types together. Okay, we got point V1, we also got point V2. Okay, let's look at them together. To really distinguish, I will try to be consistent with the color over here. Okay, so let's say this. We have point V1 and we declare P1. And also we have point V2 and we got P2. Remember, point V1 does not have the customized version, and point V2 does have it. Okay? So now let's look at one by one. Don't worry about the comments I wrote over there. Okay? Just look at the assertion. Okay? The first one I want you to look at is this one here. What about assert false, P1 equals P2? Your intuition might tell you, let's draw it. P1 is pointing to, over here, point V1, x, y, 3 and 4. And P2 is pointing to a different object, however, it's of different type. It's going to be point V2, different types, notice that, okay? Even though the structure is very similar, it's deliberate. So now, over here, do you think the assertion is going to pass or fail? Okay, I heard pass. That's intuitive, I agree. However, it wouldn't even compile. I tell you why, okay? I tell you why that's the tricky part. Because remember, let's not worry about assert false for a moment. If you only look at P1 equals P2, that means we're comparing the addresses. You cannot compare the address of Apple and the address for banana. That's what Java compiler would disallow you to do. So that's why it simply wouldn't even compile, even though they really point to different objects. But it simply doesn't make sense to make the comparison. Okay? Does not even compile. There's no pass or fail. Okay? Similarly, if you say P2 equals P1, also it does not compile. Now, here, something is a little bit exceptional. Okay? Let's look at these two over here. I said before, assert saying is pretty much like P1 equals P2. I said almost like. This is where the exception comes. If you say assert saying P1 and P2, would it even compile? Since it says exception, so it will compile. P1 and P2, if you put it here, even though P1 and P2 are of different types, it will still compile. However, you're just going to fail because they point to different objects. It's a very subtle details you have to know. Okay? Let me recap once more. Where basically our intention is we try to compare the addresses of P1 and P2, and they are simply of different types, PV1 and PV2. So there are two ways to compare them. Either you can say P1 equals P2. That's what we have learned so far, since 1022. In this case, this primitive operator simply wouldn't allow you to do so. You can only compare addresses of the same type. So this would not even compile. On the other hand, this assertion over here, assert the same. It can take any objects, even though they are of different types. But in this case, since they are referring to different objects, so it's going to fail anyway. So know the difference. The former case, it does not compile. The latter case, it compiles but fails. Okay? Okay, now finally, I would like to compare these two assertions together. I want you to look at these two. Look at them first. Ignore the comments. The comments are just for your after-class study. Okay, try not to look at them. Okay. P1 dot equals P2 versus P2 dot equals P1. Okay, and then first of all, can you just try to see if these two assertions, remember I said assert false, right? Since I say assert false over here, these two assertions only pass if the equals expression will give you false, right? Do you think these two assertions are going to pass? If you think they're going to pass, that simply means these two equals result will simply be false, right? That's what I think. I can tell you that's the case. So we can move further. But now the question that's even more important is, why both cases will give you false for the equals result. Do they come from the same reason or different reason? That's very important. Okay, let's go over this together. Again, you have to decide which version of the equals method will be called. Basically, it can be either default version from the object class or the customized version. Okay, so now you have to look at the context object in both cases. In case number 1, P1 is the context objects. In case number 2, P2 is the context objects. If P1 is the context objects, then which version do we call? Well, it should be the default one, right? Default one will boil down into P1 equals P2, right? We simply just refer to this particular version, default version. Question?
Well, I just wanted to comment.
Yes.
It might seem a little bit weird because if you look at the other one, we just said you're not allowed to do that, right?
Which one?
So like at the top where it's assert false P1 equals.
Oh, you mean over here?
Yeah.
Oh, yeah.
Because it's taken in as
I agree. I agree with you. Yeah. So what Jordan's comment was, if you look at it again, if you simply use the equals operator over here to compare the addresses explicitly, it wouldn't compile. On the other hand, in this particular case over here, since we are calling the default version of the equals, even though it's doing the same thing, but we can compile and check it, right? That's kind of the programming details you have to get used to.
because it's taken in as.
Yeah, good. Yeah. Okay, that's about first case. I like the comments, yes. So now for the second case over here, the context object is simply just P2. Okay, so now we got to decide P2 is of type point V2 over here. So now which version do we call? Customized version. Let's review very quickly. The customized version is over here. Customized version, which means we somehow to see, and now if we compare the customized version, that means this block of code will be executed. And now, can you see P2 and P1, right? So now, which branch are we going to hit? Well, that's exactly what I just went through, right? In this case, because over here, they are of different types, right? So we're just gonna return false. Okay, that's exactly how we're gonna hit. Okay, so this will also be false, but it's for a different reason. It's simply because P2 dot get class is not equal to P1 dot get class for different reason. So be prepared for a written question like the following. I give you the definition for point P1, point P2, okay? And then I might give you two assertions like that. And then first, question number 1, which one pass and which one fail, right? Question number 2, explain why. Okay, something like that. But if you really follow my explanation, it should be safe. Nothing to worry. Anything you want me to explain more, or I can move on. Can move on? Okay.
Object version of dot equals.
The default version.
Default version of dot equals, like we will just compare the
References.
references,
Mhm.
but what if like the references but the class is different?
What you're trying to say is, oh, I see what you mean. You're basically saying the following. I see. Basically, it's a good question. The question is, you can see P1 over here and P2 over here. I simply say this assertion, this dot equals boils down into P1 equals P2, right? But you don't really explicitly write this equals by yourself. In this case, I do, right? I just say P1 equals P2. Java does not allow you to do this explicitly just by yourself. However, if it turns out to be some definition of the method, which is the default version of the object class, right, the equals method, then we're checking this, even though P1 and P2 are of different types, that's okay. At the runtime, Java runtime will be able to see they are different objects and of different types, so they will give you false. Okay, yeah, that's good observation. Guys, any more questions? Are we okay? Okay, good. I want to go for one more detail, and then oh, actually, not yet. Well, I forgot this part, sorry. I thought, okay. That's only about the assert equals. I want to go over how you define the slightly more complicated equals method. That's also very important, okay? Again, but we went over this example already last time. I want to strengthen your understanding, okay? And do some code tracing. Remember, we talked about how you can define the equals method for a person. A person has 4 attributes: first name, last name, weight, and height. and the constructor over here. And then we got the equals method here, making sure if the two persons are equal, that means all the attribute values are equal. Notice one thing here, which I want to emphasize once more. You can see over here, we try to say this dot first name dot equals, and this dot last name dot equals over here. Now the question is, which equals method are we calling here? Default? Okay, how about this? What's the context object for equals here? This dot first name, this dot first name, this dot last name, right? So these are the context object. First of all, let's agree. That's a context objects. And what's their type? First name, last name? Look at the definition here. String. Agree? Well, I didn't make it up, so they're declared here, right? So they are string type. So we do have equals method in the string class to compare contents. Okay, so these equals are the redefined version in the string class. Remember back in 1022, I said every time you want to compare strings, don't use equals equals, use dot equals, right? Back in 1022. Okay, so we do have a redefined version for string. Okay, you can see over here, inside the equals method for person, we are making use of the equals method in string. And that's very common. You want to reuse the equals method whenever necessary. How do you judge which version is being called? Look at the context object. That's the golden rule. Okay, let's look at the person collector. So we got person collector over here, and we just got one attribute, person array, and also some counter over here. And then we simply initialize the array, and then we just add a person. Okay, the equals method is over here. The customized version is over here. Okay, basically you just run a loop. First of all, you do some decision here. If this the number of person equals other than number of person, which means it contains the same number of person. In that case, we bother to check further. Otherwise, we don't bother. They should not be equal. If they have the same number of persons, we compare position by position. Okay. So we just start with some attribute to be true, and then start with 0 until this.nop, the same logic as before. Okay, so now we simply say equal is simply reassigned to. So now I want you to look at this expression here. Okay, let me help you with that. I want to ask you which equals method is being called. That's what I want to ask you. Before you answer, how about I give you a little bit hints? Okay. Now you can see the equals method is over here. The context object, let me highlight it, is this person's I. That's the context objects. Okay, what's the type? Person array or person? Person square brackets I, what's the type? Person, right? Because you say have a square bracket go into that particular position. Okay, so this one here is of type person. Let's get it right. Okay, and then equals is going to call the version that we just defined over here. Okay, can you see that? Basically, we're saying that in order to make sure person collector is equal, we're going to make sure every person that contains is equal. How do we make sure person is equal? Call the equals method that we already defined. We're reusing it as a helper method. Questions about this? Okay, if you have no question, we're going to go over some code together. Okay, for this, I have to visualize everything for you, but let's do it in complete details. I think it's really important. But the source code is also made available for you. Okay, let's go over line by line. So now we have, let's say we got 4 persons. Okay, we got P1, P2, P3, and P4. P1, P2, P3, and P4. Okay, let's see how we create them. Okay, I'll try to draw them a little bit small. Okay, so over here we got P1, which points to some person objects, okay? And then let's ignore the attribute names. So it's basically A, first name, little a, last name, 180, and then 1.8. That's P1. And we also get P2 over here, also of person type. And we have capital A, small a, 180, and 1.8. Basically the same attribute value, but different objects, okay? One more, we got P3. also point to a person objects. In this case, P3 is capital B, lower b, and then 200 and 2.1. For P4, do we create any further objects? We don't. We're basically saying P4 is assigned to P3. So after that, P4 is simply assigned to P3. Okay, you should be very familiar with this exercise already. Okay, so now let's try certain assertion already. First one, let me just use P1 equals P2. False, right? Different objects. And P1 equals P2. Which version is going to be called? Default version or the person version? Are you sure? We do have it, right? So forget about point V1, point V2. They are not relevant anymore. Okay? Forget about them. Okay? So now we only got person. Okay? So we know that it's going to be the person version, right? So that means P1 and P2, if their attribute values are pairwise equal, as we define the equals method, so that should be true. That's why I said assert true over there. Okay? Next one. P3 equals P4. True, right? Same objects because of alias. Okay? Because of this line, P3. Okay? Now, what about this? P3 dot equals P4. I have a question for you. If I say P3 and P4 point to the same objects, does that mean their contents are the same? It should be always the case, right? Because if P3 and P4 are pointing to the same objects, then it's a no-brainer. Their contents must be the same because the object should be equal to itself. What about the reverse arguments? If I say two persons have the same attribute values, does that mean they are the same objects? Address? No, not necessarily because P1 and P2, right? Okay, so notice that in the slide, I do have a logical argument over there. So that's just an example. So when you go through them, you will understand. Good. Let's do person collector. Okay, which is more fun. So now again, I'm gonna maybe try to visualize for you over here. So we do have PC1, point collector 1, and we have point collector 2, PC2. What I would do is like this. Let me use different color. So let's say PC1 is pointing to an object of type point collector. Okay, and then we got two attributes. We got number of points. Also, we got the points array. I'll just call PS. Okay, and then initially it will just be 0. Agree? Initially, and then points array will be initialized to be certain array. Let me just check the size. Size will be 10, just arbitrary size. Just say 10. So something like this. So that'll be starting from 0 and 1 and 2 all the way to 9. Okay, that's PC1. Agree? And then I'm gonna do some copy over here to do PC2. Oops. You know what? That's not good. Let me draw it. PC2. PC. Different objects. Number of points initially 0, and the points is pointing to an array of size 10. Initially, what will be the value for each array cell? Null. Okay, default value for reference type. 0, 1, and 2, all the way to 9. Okay, that's what we have. That's after the 2 creation over here. Okay, let's do some assertion. Again, over here, PC1 equals PC2 should be false. Good, very good. What about PC1 dot equals PC2? Again, which version does it call? Customized version, right? So I will let you cheat. Over here. So now tell me what happens here. Apparently, we are going to run this customized version over here, right? But now at the moment, the points array for both the points array over here for both objects are simply just of some default size, right? And then the number of points is simply just 0. So what does that mean? That means when you try to execute this code, let me be very precise. When you say this.nop equals other.nop, 0 equals 0 will be true. So that means we have to execute this particular loop. Do we ever go into the loop? That's my question for you.
No.
How? Let's see. The answer is no, but let's see why. Integer I is assigned to be 0 to begin with. What's the NOP at the moment? 0. So that means 0 less than 0, false. You never go into the loop for this particular case. So that means the equal will just remain to be the default value true over here. So it will just be true. Okay, you can trace it in detail once you review the lecture. Okay, so we can know very easily over here, PC1 equals PC2, the same size, 0, empty array, just special case. So it will just be true. Question?
What would be the example that get us to the null part?
The
Object equals null.
object equals, what do you mean object? Point collector? Actually, we got different cases. Maybe for the remaining part. Yeah, maybe ask me if that's has not been answered at the end. Okay. Okay, let's go on. So now let's say we add a person objects. Okay. So now let's look at this line here. Let's say this line, PC1.addPerson P1. What it will do, I'll just show you visually. So PC1 is this address here, and add one person, basically increase the counter. Oh, actually, before I increase the counter, currently it's 0. So I want to say this first position here should point to P1, right? And then increase the counter to 1. That's basically what it does. If you have trouble of how this works, please talk to me. That's going to be covered in your lab test 1. Okay? Right. Okay, so after this, that's how we add a person. Okay, so now that's it. Now let's try to do it again. If we say PC1 dot equals PC2, in this case, true or false? Intuitively, it's false, right? But how does it really return false? According to the definition of the equals method. Well, you can see apparently PC1 has grown its size from 0 to 1, and PC2 has grown its size nothing. It still remains to be empty. That means you fail this particular check right away. That means you don't even get to the branch, so you just return false right away. Okay, that's an easy case. Because if for two person collector containing unequal numbers of persons, they're just unequal. Okay, good. That's about it. And now let's try one more. What about this line here? PC2.addPerson P2. Okay, we do something similar. So now we say PC2, and then assign the first slot to P2, and then increase the counter to 1. So here comes the very interesting case. Okay. So now when I say PC, let's do a little bit warm up. How about that? Let's look at this. When I say PC1, the person's at position 0, which object am I talking about? Okay, PC1, persons is over here, at position 0 is talking about this object over here. Okay, on the other hand, PC2, the persons at position 0. PC2 is here, persons is this array, and then at position 0 is talking about this array over here. So two different person objects. If I compare them by their addresses over here, it should be false. Different person objects, right? But if I try to use dot equals, as you can see over here, again, you can see that the context object for the equals method here is person, right? So now, according to the person's equals method, two person will be equal if all the attributes are equal. In this case, are they? They are. A, and this, and this, and this, and this. They are the same. So this will give you true. Okay, be careful. Okay. So that means this will give you true. On the other hand, oh, sorry, let me do it again. So this will give you true. On the other hand, this will give you false. Okay, the previous one. Question?
So in the middle, Assert true, like what if we remove the person, just say PC1.0?
PC1.0. What do you mean?
Like remove the person part.
You are saying you simply write PC1 0 dot 0.
Yeah.
Well,
Yeah.
anyone want to help me answer?
We have the,
So what do you want to write? You want to say PC1.0?
just about like a PC, yeah.
No, English. What do you mean? Huh?
I don't like English method. Just very
No, no.
first part about the PC1 dot.
You're saying this?
Can you write it on the board?
It's, okay, how about I answer you offline? Okay, only English in class. Otherwise, unfair to other students, all right? Okay, let's see over here. All right, now, so we know that this is false, this is true. Okay, let's see the next one. What about this one here? PC1 dot equals PC2. So the previous two was simply just a warm-up. What about the third one? So it will boil down to check the same thing, but I would like to show you how. It's really important. And I'll show you very quickly on Eclipse, okay, how you can trace it. So now, when I say PC1 dot equals PC2, again, PC1 over here is context objects. What's the type? Person collector, okay? That means this version is going to be called first, agree? And then somehow we'll go into this loop over here, and then it is going to call this equals method over here on individual objects. For example, you can see PC1 at position 0 is talking about this point person object here, and PC2 at position 0 is also talking about another person object. How do we compare them? We use the equals method from the person class, right? The person class also declared this equals method. How do we compare them? We compare them according to the definition. We compare them by their weights, heights, first name, last name. Specifically, when we get to comparing their, let's say, first name over here, how do we compare the first name? We further call the equals method in the string class. Starting from the person collector equals method, we call the equals method in the person. And then we call the equals method in the string class. So we got 3 equals method being called over here. Clear? Okay, questions?
So the pretty simple method right here. But how do we skip the fourth, like the first 4 lines all the time?
I didn't really skip them. Okay, it's simply because okay, let's say this. When you say PC1 dot equals PC2, right? For, all of them over here simply just wouldn't pass. Let's go over very quickly. So this will be PC1 and OBJ will be PC2, agree? They are not the same object, so this will not be executed, agree? And also PC2 is pointing to something, so it's not null. So also this will not be executed, agree? And then also when you say this dot get class versus obj dot get class, what is that?
Because they're in that middle, but when we're using the PC1 dot person 0, the new part would be true. Because at the beginning of initiation of the arrays, like all the arrays of
Sorry, say your question again from the beginning. I want to make sure I catch you correctly.
Okay, when you had the PC1 dot person in bracket 0, the first index of
Yes.
point the person collector, it was null, right? When we started, it was null.
Okay, good. So you're talking about this particular check over here. So as soon as after PC1 and PC2 were created, where the 2 arrays agree, they were both initialized to be all null slots. I agree. However, remember there was a counter over here called number of points. That's where we keep track of how many person we have stored in each person collected so far. For initially, both are 0. Agree?
Well, we don't check the arrays inside.
No, we don't do that. We just want to know, because those will be fixed number, right? The size of the array, they're fixed number. We want to make sure the number of person that actually being stored so far, they are the same. So it's different concept.
What are you referring to the arrays themselves?
So the way we do that is by using a for loop, right? So we simply just go for the for loop and then go over the element one by one, right? You can think about this, or thinking this way. When I do this particular, When I do this particular check, this is like the check for the very first iteration for the equals method for person collector. Because I go to the first position of the person's array, I go to the first position of the person's array, and then compare them to see if they're equal. How do I compare them? I use the person equals method. Okay. Guys, I hope it's not too complicated, but if you got questions, please raise them now. Yes. Questions? Oh, you're fine. Okay, you're fine. Sorry, I thought you had a question. You mean the last one? PC1 dot yeah?
Yeah, the PC1 dot equals PC2.
Uh-huh.
You're jumping to your customized equals.
Right? You mean how do I jump there?
Yeah, because you're comparing your front like you go back.
Okay, so the reason that I went back there was, okay, so PC1 over here is the context object, agree? That is of type point collector. Sorry, person collector. Guys, please. Okay. So we got person collector here, right? That's a context object. So this equals method refer to this particular version in the person collector. Agree? Okay. So when you trace through them, as we said before, these cases will not be executed. It's mainly the customized version will be executed, right, over here, right? So we simply run a loop over the persons array for both cases, one by one, and try to see if individual person they store. For example, over here, if this first person they store are equal, and in the next iteration, we try to see if the second person that is stored is equal, right? Okay, I'll say it one more time. Okay, so after, let me see this. After this line here, up to this point, do you agree that we got only one person stored in PC1? Okay, also we got one person stored in PC2, right? So far so good, okay? And then when we call this equals method, we'll eventually run into this version of the equals method, and then we go into this loop, right? So the question is, how many iterations will we run for this loop? The number of iterations we run depends on how many persons have been stored so far. It does not depend on the size of the array. It depends on what the NOP is, number of persons. In this case, NOP is simply just one, right? Only one person has been added, so we just go for the first iteration to compare position 0. Yeah. Yeah, exactly. So over here, the equals method is going to compare position I, let's say 0, right? Position 0 with a person at position 0. Compare them, and this will in turn cause this method here, this version, equals method. Correct. Because you look at that, the equals method is over here, right? And what's the context object? The context object is this dot persons, which is a person array. When you use brackets to go further to the index, that will give you person objects. So that means you should look up the person class over here, okay? And then the person class does define the equals method. In which case, again, you'll run through the process again. It turns out you will just compare their weight, height, first name, and last name. And when you compare their first name and last name, you also use the equals method from the string class, right? I would say maybe try to trace it through by yourself just one more time, just completely after class. Yeah, if you got trouble, let me know. Let's go on, okay? Okay, one more, let's go on. Let's finish that. And let's say after that, we want to add more persons into both arrays, okay? So far, you can see that the two persons over there, let me just color them. You can see this is the person that's contained in PC1. And this is the person, this is the person that's contained in PC2. They're just different objects, okay? Let's see a different case. What I want to do over here is like this. Can we look at this line here? PC1.addPerson P3, PC2.addPerson P4. And we agree from before, P3 and P4, they're pointing to the same objects. So how does it look like? Let's look at that, okay? When I say PC1.addPerson P3, so that means currently the value is 1. So I'm going to assign position 1 to be this object here. Over here. And then increment the counter from 1 to 2. Okay, what about PC2.addPerson P4? P4 is pointing to the same object anyway. So I'm basically doing the current counter is 1 for PC2. For this position here, I will copy the address for P4, which is also pointing to this object here, and then increment the counter from 1 to 2. So now you can see that the interesting case, okay, in the memory. Basically, for PC1 and PC2, for their first stored person, they are different objects, but they are equal. On the other hand, for their second store person, which I'll highlight using blue, it's the same objects because of aliasing. Okay, so now, remember what I said before, if we are trying to run is equal on the same objects, it will be true automatically because of reflexibility, right? Okay, so let's see very quickly. So now let's have a look. What about this line? PC1.persons at position 1 and PC2.persons at position 1 equals. True. Just the blue object over here, right? Okay. What about this one here? When you say assert true over here, and then you say they're basically the same expression, but I just use equals. It should be rather straightforward because I know the previous one tells me they refer to the same objects. So now the same object should be equal to itself no matter what. So it should be very easy to answer, right? They point to the same objects, doesn't matter. Okay, finally, if I say PC1 dot equals PC2, what's going to happen? PC1 dot equals PC2, we run the same process. I'll mention very briefly. When I say PC1 or PC2, again, context object is PC1. So I will go to, again, this version over here, and I'll run this loop. My question is, how many iterations will we need this time? 2 iterations, because we got 2 persons objects. Because the number of person counter over here is simply 2. Okay, we'll do that. And now basically we're comparing, again, for each pair person, for example, let's say for the very first iteration, is this person over here the same as this person here? Equal. The first iteration, right? Is this person equal to this person? Yes, the same first name, same last name, etc., right? Second iteration, is this person over here equal to this person here? Yes, it is. Well, just the same attribute value, right? That's second iteration. Both iterations give you true, overall give you true. Okay, so over here, it will give you true. Okay, so far, right? Finally, we're almost done. Let's say I want to add more persons over here. So what am I doing here? Can you recognize the syntax? I'm doing anonymous objects, right? So basically I'm saying that PC1.add person, a third one, and also PC2 add person, a third one as well. I'm basically adding 2 different persons, but with just the same attribute values. Agree? Can you see it? Okay, let me say this. Let me try to draw very quickly. I don't have too much space. Huh? The attribute values are the same. They are different. Oh, sorry. I meant to say, yeah, they're different. Yes, I thought they are the same. They are different. Sorry. And as you can see the difference here. Okay, good. Okay, let's say this. So somehow in this line over here, I created a new person object here. And another one, I create just another new person object here, right? Okay, the person objects. Okay, I'll just highlight the difference. One is 175, and the other one is 165, and 1.75, and 1.55. They're simply different. And then over here, I say add person. So that means for PC1, I'm going to assign this third one to this object. Okay, and then increment the counter to 3. And then for PC2, I'm going to assign this counter over here to this new object here, and then increment the counter from 2 to 3. That's the complete picture. Okay, let's try to answer. So now I say the following: PC1.persons at position 2, which is this object here, and PC2.persons 2 over here, this object here, right? They are different objects. Of course, this is going to be false. Are they equal though? Are they equal? No, they are not. Because if you run the isEqual method, if you run the equals method for the person class, their attribute value are not the same, so they are not equal. Okay, so that will be false. That's also false. And finally, if you try to see PC1.equals PC2, okay, so what you will see is even though they are of the same size over here, and their first person is the same, second person is the same, but third person is not the same. So overall, not the same. Okay, that's the complete example I'll let go over with you. Do go over them, but there's one more thing I want to show you in the Eclipse just to verify. Okay, you can also try to reproduce what I'm trying to do here on Eclipse. Let me do that quickly. Okay. On Eclipse, the source code, once you get it, go to the test person collector. Okay, go there. I want to first of all show you the following. Let me go to point. Okay, there's several things I would like you to try to do by following the lecture recording. First of all, test points is a JUnit test. Exactly what we have gone through. I want to put a breakpoint over here, P1 dot equals P2. You know what? How about the last two? I think that might be better. One breakpoint here, line 60, and one breakpoint here, line 64. Okay, it's already there. I want to show you exactly the version of equals method that will be called. Let's go back to the point example. Remember, P1 was declare of type. Over here, let me see what the type. Okay, point V1, and P2 is of type point V2. Okay, let's remind ourselves. So now let's predict what's going to happen. What's going to be the version of equals being called from the first one? Point V1, right? Which is the default version. Let's verify that. So I double click on this, and then I'll right click on test points and say debug as JUnit test. If I do that, let's let the execution stop there. Okay, it paused over there. So now I would like you to try to step into. If I step into, that means I want to step into the execution for the equals method. And as we predict, because P1 is of type point V1, so we'll go to default version. So if I say step into, that's exactly the default version that's in the object class. Agree? Okay, let's do one more. And then I can say step out. So now I will say step over again, go to the next line. So now for this line here, the context object is of different type, which is point V2, which does have a customized version redefined. In that case, if I say step into, which version would I see? Customized version in point V2. Let's verify that, and then we're done with this particular illustration. So let's say step into, and then you can see it's a different equals method, right? You can see that's exactly in point V2, and then that's exactly a customized version we had before. Okay, try to reproduce this one, convince yourself. Different versions of the equals method are being called. Okay. One more illustration I want to show you. One more. If you go to the same package here, the same project, example equality, I want you to go inside persons and go to test person collector. What I want to show you is this. I want to show you how the PC1 equals PC2 is executed, especially the chain of calling the equals method. Okay, I want to show you once more. Okay, so now I want to right click on this particular test person collector class, debug as JUnit test. Let's see what happened. Okay, so now we are pausing at PC1 equals PC2. So now if I say step into, which version? PC1 equals PC2. I remember PC1 and PC2 customized version in person collector. Agree? Okay, if I say step into, that's what's going to happen. If I say step into, and that's exactly in the person collector class. That's the equals method. Okay, I want to go a little bit further. If I say step over, step over, step over, step over, step over. Now the first iteration, right? So now you can see I'm now in this line over here, equals, okay, let's just put this expression here to make it clear for you. So this dot person's I dot equals other dot person's I. If I say step into again, which version? Customized version in the person class, exactly. Okay, let's verify that. One more, and then if I say step into, what I will see is exactly this equals method in the person class, right? And then, not to really have to waste your time, but if once I get to this point, if I try to step into which version? The string class, right? Do the same exercise by yourself. Okay. Okay, I got about maybe 10 more minutes. This is what I want to do. Since I talk about all equals method, right? Why don't we just finish one last bit? And then I'll do the compare to and hash code Monday. So which means, what if I talk about today, even though it's not new, but it will be covered. It's just helping you review the concept. I want you to look at this slide here. That will take about 10 minutes. I think that's about right. Now, I want you to look at the equals method definition here. for line number 5. Okay, line number 5. Line number 5, you can see that I'm trying to do a OR logical operation there, right? Or I'm saying that I'm going to return false at line number 6 if either obj is equal to null or the class of this is not equal to the class of obj, right? That's basically logic, okay? I have a question for you. If you look at the right-hand side of the OR, we say obj.getClass. So what I'm talking about specifically is this expression here. I say obj.getClass over here, right? I have a question for you. If at the runtime, if I got obj being equal to null, okay, what's going to happen? Okay, let me ask this way. If obj happens to be null, am I going to get a null pointer exception from that? No, right? You want to say something? Yeah, short circuit, right? Okay, you guys know very well. Okay, very good. Okay, so now let me ask you the following question. Okay, you understand very well. What about this version over here? Can I just imagine that if I swap the order of the two? If I say this.getClass not equal to obj.getClass or obj equals null, I simply swap the order. So now, is it possible to get null pointer exception? Right? Again, we evaluate from left to right, right? And the obj equals null is only checked after we call the method, so it's not going to work. Okay? Does it make sense? Basically, it's everything about the short circuit that I would like you to go over. Okay? Well, since like maybe almost 10 minutes, right? Why don't we do a little bit compare too? We'll save some time Monday. How about that? I'll let you go a few minutes early, I promise. Let me just do one informal example together. Okay? But everything about equals will be on lab test 1. You should really study them through. But I think the example we went through today, hopefully that really help you understand. Okay? And remember the birthday book example you have to do, right? For the practice problem. Okay, so now let me do some informal example with you just to motivate why the compare to or comparable construct in Java can be useful. Let's consider the following scenario. Let's say we have a company with employees. So let's say each employee, they got 2 attributes. They got their ID, which is number, and also they got their salary, which is double. Okay? Let's say, for example, we have, let me show you on the iPad over here. Okay, let's see this. I want to talk about it informally, and then once we get a concept, we'll see on Monday how we can turn it into Java. Okay? What I want to show you is this. So basically, if you learn about database later, so this is how you store information in a database, like a table. So we got basically 3 rows over here. Each row corresponds to the record for an employee. Alan, numerical ID 2, and salary this much. Okay, so we got 3 employee, Alan, Mark, and Tom. Okay, that's about the simple database we talk about. So now this is what we would like to do. Let's say this is a problem. Let's say if we want to do some annual review on the employees, we want to generate a report, but somehow you don't just want to present them in any arbitrary order for the employees. You may want to sort them in a particular way. So let's talk about 2 different ways of sorting them. First of all, informally, and then we talk about later how you can put it in Java. Okay, the Java part is really easy. Okay, so there are 2 ways for you to sort them. The first way, easy, let's say, how do we sort according to IDs? And also when you say sort, what do you really mean? Let's say if you want to sort an array of integers, you have to specify, do you want to sort in increasing order or decreasing order, right? So somehow you want to know, how do you determine to say one employee is smaller than or equal to another employee? How do you define, right? That's kind of the question here. But now, given that we say that we're going to sort based on the IDs, so why don't we simply represent each employee just by their ID for the sorting? So we only look at this particular column over here. and sort based on that. In this case, let's say we sort from the smallest to the largest. In this case, the smallest should be Tom, right, with ID 1. So Tom should come first. And then we should get Alan, which comes second. And then we should get Mark. So the first way of sorting, we are only sorting based on one criterion, just based on the ID. Very simple. And then we say that one employee is smaller than the other one if their ID is smaller. Okay? I'll say employee smaller if ID is smaller. And we'll see how to translate this into Java next week. But let's see the second way of sorting, and then we are done. Okay? So now let's say we want to do a little more complicated of sorting for the report. Let's say we want to sort based on salaries and IDs, and somehow we have some priority to see which criterion to do first. We're going to say compare salary first. Okay? If the salary of one employee is maybe larger, then they should come first. Okay? So larger employee comes first. Okay? And also, if the two employees have the same salary, if for example you can see Mark and Tom, they have the same salary, then which one should come first? Given that the ID is unique, and then we say compare ID. Smaller one comes first. I want you to pay attention to one thing. When I say come first, in both cases, in one criterion, I say the larger one comes first. In the other one, I say the smaller one comes first. You can see they don't have to really agree every time, right? Not necessarily smaller one must come first or larger one must come first, depending on your criterion. Okay? So now let's see this. Now, how can we sort it? What should be the final result over here? So we should really compare salary first. So whoever is the maximum, in this case, okay, let us have a look. Who should come first in this case? Alan, yes, Alan. And then we run into a case where these two guys have the same salary. So whoever got the smaller ID should come first. And then we got Tom, and then we got Mark. Agree? Okay, I'll stop here. And then lab test 1 is going to cover everything about equals. I'll make it emphasize again on the Moodle. I'll see you next week.